We finished this topic with two final application examples. They're a bit trickier than the previous ones we've looked at. Let's take a look. Example 3. A stamp collector mounts stamps into a collection booklet. One of the collector's favorite bird stamps measures 4 centimeters by 5 centimeters. The stamp is to be mounted on a sheet of paper that has an area of 110 square centimeters, such that there is a uniform border around the stamp. Determine the width of the border necessary for this to occur. All right, so what is going on in our problem? Hopefully you can visualize, and let's set up a diagram to actually put a picture to these words. We have a stamp that's approximately 4 centimeters by 5 centimeters. So let's see if we can draw a stamp approximately 4 centimeters by 5 centimeters. And let's label the sides. So this side, let's call 4 centimeters, the width or the height of this stamp. And then this side, the length, let's call 5 centimeters. Okay, so far? This is 4 and this is 5. All right, so we have our stamp. Now, what is it that we know about this stamp? Well, we know it's going to be mounted on a sheet of paper that has an area of 110 square centimeters, but more importantly, when we mount this stamp, we want a uniform border around the stamp. Like a picture frame, right? We want to place this stamp in the middle of the paper so that the border around the outside of the stamp is the same width on each side. Now, let's see if this would work. Let's say this is our piece of paper that we're mounting on. And if that's the case, then this border of uniform width means that this distance here is the same as this distance, is the same as this distance, is the same as this distance. Does that make sense? Now, we don't know what that width is. In fact, that's what we're trying to figure out. So let me call that distance x. So x centimeters is how wide this border is. And because it's uniform, that means that this will also be x centimeters. And up here, this distance will be x centimeters. And over here, this distance will be x centimeters. Does that make sense? So it's the same all the way around. All right, so there's our picture. We now have to go about trying to set up an equation. Well, what do we know? We know that the sheet of paper is 110 square centimeters. This outside sheet of paper is 110 square centimeters. So let me write that down. So the area of the entire paper on the outside, so let me actually trace over that. So the area of this outer rectangle here is 110 square centimeters. And to get the area of a rectangle, we need the length, or this side dimension, and the height, or the width, this side dimension. So let's figure out what those dimensions are. So for the length, which is this side here, what do we know? Well, we know that the length has to be at least 5 centimeters, right? Because from here to here, right, if you look from here to here, we know that is 5. That distance is 5, right? And from here to here, what is that? Oh, well, we know what that is as well. That is our uniform width, x. So far, from here to here is 5, from here to here is x. Now, how about this part of the length? Well, that's also this width here on the border, and that's also x. Oh, so what does that tell us? That tells us that this length here, along the top, or if you like the bottom of the rectangle, is 1x plus 5 plus another x, which I could write as 5 plus 2 x's. Do you see that? 1x plus another x. So that's 2 x's plus 5. Perfect. Now, this side, the height side, how can we represent that in terms of x? Well, notice from here to here, do you see this here? That we know is 4 centimeters, right? That's 4 units from here to here. And this part here, from here to here, is x, because that's the width of the border. And this part here is also x from here to here. So together, to get the entire width or height of this outer rectangle, we have x units plus 4 units plus x units. So let me call this the height of the rectangle. And so the height of this particular rectangle is going to be x plus 4 plus x, or if we like, 4 plus 2x. And that's going to be the height side, right? So we have the height, and then we have the length. Now, the area is what? It's the height times the length. So let me write down the height times the length of a rectangle, or if you like, the width times the length of a rectangle is equal to the area of that rectangle, right? And so we can put this all together now. From our picture, we are just going to focus on this outer rectangle, okay? So again, we're going to ignore the middle stuff for now and only focus on the exterior of this rectangle. The height is defined by the pink, which is 4 plus 2x. So we would say that the height of this rectangle is 4 plus 2x. And the length of this rectangle is 5 plus 2x, right? And the area of this entire rectangle, the 4 plus 2x times the 5 plus 2x, that area is 110 square centimeters. So now we just have to solve this equation. This equation here will solve our problem. We multiply out using the distributive property, right? We're going to take 4 times 5 and 4 times 2x. And so that's going to start us out with 20 plus 8x. Then we're going to multiply the middle stuff, 2x times 5 and 2x times 2x. And that's going to give us 10x plus 4x squared. And that together gives us 110. So far, so good. This is now a quadratic equation, an equation of degree 2. So we bring all the terms to the left side, we collect them, and set it equal to 0. So we have 4x squared plus 18x, because the 8x and the 10x get combined. And then we bring the 110 over, add it to the 20, and that gives us minus 90 equals 0. So we've collected all the terms to the left. Lastly, we want to solve. We can either complete the square, use the quadratic formula, or factor. Now, my method of choice is factoring, if possible. I'm going to start, though, by noticing that each of the terms in this equation is divisible by 2. Do you see that? So if we divide each term by 2, that just gives us a slightly simpler equation to work with. So 4x squared divided by 2 is 2x squared. 18x divided by 2 is 9x. And 90 divided by 2 is 45. So we are simply solving the quadratic equation. 2x squared plus 9x minus 45 equals 0. All right, let me bring it over here. Again, you can use the quadratic formula. You can complete the square. I'm going to factor. And when I factor, I like to use the box method. So I'm going to go through it very quickly. You should be getting really good and able to do it at this point. If not, go back and practice your factoring modules. In my box method, I want a column for 2, so the factors of 2 go here, and I want a column that will give me factors of negative 45 right here. So let me take 2 times 1. And when I pick my factors for negative 45, I want to do it carefully so that when I cross multiply, I get a sum that's equal to 9, right? What could I do? 9 times 5 will not work. Oh, how about 3 times 15? Because 3 times 15 is 45. And if I put the negative on the 3, 15 times negative 3 is negative 45. But more importantly, when we cross multiply, 2 times negative 3 is negative 6. 1 times 15 is 15. And when I add those together, that gives me the middle coefficient I'm looking for. So this box factors this polynomial for me. The first factor is determined by the first row, 2x plus 15. The second factor is determined by the second row, x minus 3. And now we use the zero factor property to solve. We have 2x plus 15 equals 0, or x minus 3 equals 0. X is either 3, or, let's see, we're going to solve this by bringing the 15 over, so it becomes negative 15, divide by 2, so x would be negative 15 halves. Phew! All right, so we have our quadratic equation that we've solved and gotten 2 answers. X equals negative 15 halves, and x equals 3. The last step is to answer our problem. It says determine the width of the border. What was x again? Recall, x was the width of our border. X was this distance that's uniform all the way around the stamp, right? So either x is 3 centimeters or x is negative 15 half centimeters. Well, obviously, that border can't be of a negative width, right? So the only answer that makes sense would be that this width here is 3 centimeters. So the answer is determine the width of the border. We would say that the border, and I'll write it right here, is 3 centimeters. How can we check to make sure that makes sense? Well, let's go back and look at our problem. If our height is 4 plus x, that would mean this would have to be 3, right? And this would have to be 3, and so that means this height would be 3 plus 4 plus 3, or 10. So that would tell me that this height here of this outer rectangle would be 10. And it would tell me that the length is x, which we just said was 3. And this x is 3, so it would be 3 plus 5 plus 3, which is 8 plus 3, or 11. So the length along here would be 11 centimeters. And if you have a rectangle that's 11 centimeters by 10 centimeters, the area would be 110, which is what we wanted to begin with. All right, so the final answer of our problem is that the border is 3 centimeters wide. Phew, that was a long one. The next one is just as difficult. But if you go step by step and draw a picture to get started, it should be able to be broken down into a simpler process for you. Let's see how it goes.